Hello my students, welcome to my channel My Target 100%. I think all of you have seen my last video. In the last video we discussed about the rotational motion, what are the terms connected with it. That was the, what are they? Anybody? One is the particle, then system, external force, internal force, rigid body and center of mass. We discussed in the last video. Okay. Today we have to discuss about the types of motion of rigid body. Types of motion. Types of motion of a rigid body. I think clear? Okay. So generally there are three types of motion in a rigid body. Okay. One is pure translational motion. Pure rotational motion. And third one is combination of translational and rotational motion. Let us discuss one by one. Okay, how can you understand and what are the differences between them? First try to, I am telling, I will repeat the same in every video what I am telling. In pure translational motion, what you will see in figure I will draw the diagram. The velocity, each particle, velocity of each particle remains same. That is linear velocity. But the velocity of the particle remains same, that is angular velocity. Here linear velocity same, angular velocity same, but here is there is no angular velocity, here is angular velocity but constant, but linear velocity is different. But here there is a combination of both linear velocity and angular velocity. Can you understand? So let us discuss one by one. That one is pure translational motion. Suppose you are considering inclined plane. This is inclined plane. Clear? Suppose this is inclined plane. Clear? This inclined plane, you give the name better A, B, C. This is angle theta, and you are just keeping a rectangular wooden block. This is a rectangular wooden block. That block means it is a object that consists of number of particles. You just consider two particles. Suppose this is particle 1 P1, this is particle P2. One is P1, another is P2. Okay. When you are keeping that rectangular block in an inclined plane, it slides down. What will happen? The linear velocity of all particles remain constant. Linear velocity same. Okay, but in case of pure rotational motion, okay, just I am erasing that one. So if you will not understand, you can take the screenshot. Okay, suppose you can take, this is the rigid body. The fixed axis on which the rigid body rotates, that is axis of rotation. Suppose this is one axis, this is the center, assume this is the center, okay, and this is the suppose x axis, this is y axis, this is z axis, okay, and you are considering that system consists of number of particles. Suppose particle 1, this is particle 1, okay, particle 1 center C1, and this one is radius up to r1. Suppose this is another particle center, that is this one you would consider, not another point. So this is center 2, particle 2, this is radius 2, and suppose this is the center 3, this is lies at the center. Suppose this is this C3 is here. Okay, so radius is 0. What you are observing? Actually, when that particle will move, that particle will move. What will happen? What will happen? You see that one. All the particles of the system will revolve around the axis. It is xy plane, along the z axis particles are moving. Here is, this is the distance. This is the distance. That means when a rigid body rotates, the angular velocity of all particles remains constant irrespective from the axis of rotation. But the linear velocity is different because it depends on the distance from the center. So V is equal to omega into r. So V proportional r. That's why. But here, but suppose you want to know about more things, what you will take? Consider another one. Suppose you are keeping one wheel, just the car of wheel of a car, you are keeping this one in this one. Okay, this one. Clear? On the horizontal surface, what will happen? On the horizontal surface, here the velocity is how much? V. This is V. This is also V. In case of translational motion, if you are keeping, आप एक कार का व्हील ले लो, जो काच बाटी जो बोलते हैं शीशा में उसको ले लो, और कहीं एक गुल्ली डंडा जो खेलते हैं उस वाला को ले लो, जस्ट रोड पे आप गिराते हो. दैट मीन्स वो क्या कर रहा है? Until your translational motion, it always the linear velocity constant. This one is constant. But when it rolls, that means what I am telling you, try to understand. If it slips, a rigid body, while you are considering it is pure translational motion, if it slips without rolling over the surface of a, without rolling the surface, without rolling, आप ऐसे सीधा गिरा दिए तो सीधा हो जा रहा है. इफ इट इज गोइंग ऑन इन ए स्ट्रेट लाइन, इट इज ट्रांसलेशनल मोशन. बट व्हेन इट रोल्स, सो